Hello everyone, here I am with my new video on sets in Python and application of set operations on list. So, firstly, we need to understand what is a set. A set is an unordered collection data type that is iterable, mutable, and has no duplicate elements. So, it is based on a data structure known as hash table. And since sets are unordered, we cannot access items in the sets using indexes unlike lists. So first, let us understand how we work on sets, creation there, and some methods on sets. So here you can see a command S1 is equals to set, and in the brackets it is 1, 2, 3, 4 and 5. This is the one way in which you can create a set. Here using the print command, I have printed my set and you can see here 1, 2, 3, 4, 5 in the curly braces which denotes this as a set. There are other methods to create a set. Let's have a look at them. In the next command, you can see I have written the command S1 equals to curly braces 1, 2, 3, 4, 5. This directly written curly braces creates the set S1 without any use of the set method over here. Therefore, here you can see the output in which you can find a set printed over here. So this was another way to create a set without using the set method. Okay, but with this set method, you cannot create any empty set. Likewise, I have written a command over here s1 equals to the empty curly braces, and when I print this set, I get empty curly braces as it is. So this is totally incorrect way to create an empty set. So in order to create an empty set, you need to use the set method in that. When I used the set method in my command, I got a empty set, which is the correct way of creating an empty set over here. Okay, so this was about the creation of sets. Now, earlier I told you that it is no duplications in sets. So let us check whether it is correct or not. Here I have declared a set 1, 2, 3, 4, 5 and again 1, 2, 3. That means I am repeating these elements 1, 2, 3 again in the set. And when I print this set using this print command, what I can see in my output is just 1, 2, 3, 4, 5. That means repetition of the elements was removed. Hence, the set removes the duplicate values. This was about the duplication of elements. Now let's come to addition of elements in the set. We can add elements to the set using some different methods. Firstly, we will have a look at the add method. Here I have created my set as 1, 2, 3, 4, 5, and in the next line with the command s1.add in the bracket 6. This add method helps me add this element 6 to my set. Now, when I print this set using the print command, what I can see is my set has been included number 6 in it. So this is one way in which you can add the element. But with this add method, you can add a single element at a time. So to add more than one elements, lists or another sets to your set, you need to have a different command. Let's have a look at that. I have created a set 1, 2, 3, 4, 5 again, and to add more than one values list or set to my previously existing set, I have used here a update command. This update command helps you add multiple values to your set. When I use the set command and I have passed the values 6, 7, and when I print this set, I can see that my set has been created with the values 1, 2, 3, 4, 5, 6, 7. That means 6 and 7 both are added to this set. So, similarly, using this update command, you can also add another set to your previously existing set. Here, you can have a look. I have created a set S1, which is equals to 1, 2, 3, 4, 5. And there is another set S2, which is 8 and 9. Now, when I use the update method on the set S1, with the list 6, 7 and the set S2, this means that I have added the list 6 and 7 and also the set S2 which has the elements 8 and 9 to my set S1. Now when I print this set S1, what I can see is my set having 1, 2, 3, 4, 5, 6, 7, 8. That means this list and the set both are added to this list. So using the update command, you can have multiple elements added to your previous set. So this was about adding the elements to your set. Now let's talk about removing an element from the set. To remove an element, there are two methods, remove and discard. Let's have a look at them one by one. Here I have created a set 1, 2, 3, 4, 5. And here I am using the command s1 dot remove in the brackets 3. This remove method helps me remove this element 3 from my set. So now when I print this set, I can see only the values 1, 2, 4 and 5. That means this 3 has been removed from my set. Now with remove method, the one thing that goes is when I remove an element which is not present in my set presently, there comes an error key error. Here I have used the remove method on an element 6 which does not exist in my set previously. So therefore this gave me an error as key error 6. That means the element 6 does not present in my set S1. So to remove this error, we can use the method discard over here. This discard method helps you remove the elements, but with together with the elements present in the set, it also removes the elements which are not there in the set. That means it does not give you any key error even if you remove any element which is not present in the set. Likewise, here what I have done. Here I have created the set 1, 2, 3, 4, 5 and I have used the discard method on the same set S1 and I am here removing the element 6 from my set. So when I print the set S1, I can see the elements 1, 2, 3, 4 and 5 and there is no key error message displayed over here. So this was about some basic addition, remove and creation of the set. Now let's move to some intersection, difference and union methods which we can perform on our sets. Okay, so here I have created three sets, S1 as 1, 2, 3, S2 as 2, 3, 4 and S3 as 3, 4 and 5. Now, to find the common elements between any two sets, I can use an intersection method to find those common elements. Here I am creating another set as S4 and here I am using the command S1 dot intersection S2. This means the intersection method is applied on the set S1 and it gives you the common elements which between S1 and S2. So when I print this set S4, what I get is the set which is having elements 2 and 3. As you can see here in the sets S1 and S2, there are two elements common, 2 and 3. Here, I can also apply this intersection methods on all the three sets together like I have done here. Here I am creating a set S4 and here I am writing the command S1 intersection In the brackets I have given S2 comma S3. So this finds a common element which is between S2 and S3 and then intersection of S1 with that common element of S1. That means it gives you the common elements between all the three sets. So when I print this set S4, what I get is this 3, which is, you can see, common in all the three sets. So this was about the intersection, which helps you find the common elements between two sets. Now we can talk about the difference. This difference method helps you get the elements which is present in one set but not the another. So here, see what I have done. I have again created three sets, S1, S2 and S3, 1, 2, 3, 2, 3, 4 and 3, 4, 5 respectively. Now here I am creating again a set S4 and I am writing the command S1.difference in the brackets S2. This command means that this difference method is applied on the set S1, and what the output I get when I print the set S4 is the element 1. That is the element which is present in S1 but not in S2. So in order to get the elements which are present in S2 but not in S1, you can also flip the positions. Like here you can use S2 instead of S1, and here you can use S1 instead of S2. So here you can get the element 4 which is present in S2 but not S1. This is because this difference method is applied on the set S2 this time, not the set S1. Okay, so similarly using this difference method, you can also find the difference of all the three sets together, like the intersection you got of the three sets. Here I have created again the three sets, and again I am creating a set S4 with the command S2 dot difference in bracket S1 comma S3. This command gives me the difference between all the three sets. So when I print this set S4, which is the resultant of difference between all the three sets, what I get in the output is this set, empty set. Because here you can see that there is no common element, there is no element left between the three sets that can be represented as a difference. So therefore the output is empty set. So now when we talked about the difference method, what you can see here is when I apply the difference method on S2, I get the element which is remaining in S2. And when I apply this difference method on S1, I get the element 1 which is remaining in S1. So what we can do in order to get both the remaining elements of both the sets, like I can get the output 1 and 4 together. So for that we have another method which is called as symmetric difference. This method, symmetric difference, gives the difference, that is it outputs the difference elements of both the sets. Here I have created the set S1 and S2, and this S4 I am creating it S1 dot symmetric difference S2. This symmetric difference helps me get both the elements 1 and 4 in my output. Now when I print the set S4, what I can see is both the elements 1 and 4 in my output. So in order to get remaining elements of both the sets, instead of using difference method, you can go with symmetric difference method. So this was all about basic methods and operations on sets. Now let's see how we can apply them on our lists. So here what I am doing is I have created a list 1 2 3 1 2 3. Now what I want is I want this list without the duplicacy of elements. So what I can do is I can convert this list into a set, and if I want I can again cast it to the list like I have done here. I am creating this list L2. Let's remove this list casting over here, and what I have done is I'm creating a list over here L2, and I have casted this list L1 to the set using this set method. And let's see what happens when we do that. So here you can find a set of the elements 1, 2, 3. That means the duplicacy of the elements has been removed. So, and if you want, you can also cast this to the list back like this using the list method. And now when I print this list L2, what I get is a list instead of set because I have casted this set again to list. So my inner methods helps me cast this L1 to the set, and this list method again helps me cast the set L1 to the list L1 without any duplicacy of the elements. So now let's have a look at some practical applications. So here are three lists. One is students. It consists of some names of the students. And here is again another list. M club, which consists the list of elements of students who are in music club. And this art club list helps us to know the name of students who are in art club. So firstly, to find the students who are in M club and also in art club, what we can do is we can use the intersection method on the M club and art club. So here I am writing the command result equals set M club. For the intersection method to work on, we need to convert this M club list to a set. It is mandatory because this intersection method works only on sets. So in order to do so, I have casted this M club list to a set, and with dot intersection method, with this dot intersection method, what I have done is I have passed the art club in the parameter. To cast this art club list to a set is optional. If you want, you can also cast it, and if you don't want, you can even leave it. So when I print the result, what I get is what is the common element between, or common student between both the clubs. That means Stuart is the element student who is in M club as well as art club. Okay, so now with this intersection we can also find the difference. Now let's see which students are not there in both the clubs, M club or art club. So for that I have used the difference method on this students list and passed M club and art club both as parameters of my difference list. So here while I print the result, what I get is this Ricky. So Ricky is the student which is not there in both the clubs, that is M club and art club. So converting this lists into set makes your things bit easier, because while iterating or membership test in the list, what I mean by membership test is like if you write some commands like this: if Ricky in M club print found. So this Ricky in M club is what is known as membership test. So when you do this for a list, you get a more complexity as compared to set, because the complexity for the list is big O of n, because in list it iterates through each and every element to check whether your element you are searching for is present or not. But for set, it is big O of 1, which is constant and which reduces the complexity of your program. So when you are using the big list or something, better you must go by casting them into a set, which would be more helpful. This is all for this video. Hope this will help you. Thank you.